You know that feeling, right? That sinking feeling. 1 minute, everything's humming along. Could be your coffee machine, your car, maybe something critical at work.
Yeah, running smoothly.
And then the next minute, just silence. Or maybe worse, some awful grinding noise.
Yeah.
It just stops completely out of the blue.
Ugh, yeah. The worst.
And it's not just annoying. It completely messes up your day, right?
Yeah.
Causes delays you really can't afford. And there are always those hidden costs you didn't see coming.
Always.
But what if I told you that a lot of those headaches, especially the ones involving machinery, aren't just bad luck? That they're actually predictable,
Right.
maybe even avoidable?
That would be pretty significant.
Well, today we're doing a deep dive into exactly that. It's called proactive maintenance strategy.
Yeah.
Basically, a systematic, kind of logical way to keep things running smoothly, efficiently. We've dug into some really great specialized training materials.
Yeah, some really insightful stuff in there. They take these sometimes complex industrial ideas and make them really practical, actionable.
Exactly. So our mission for you listening is to give you a shortcut, really.
Mm-hmm.
A way to understand why equipment fails, sometimes in surprising ways, and then how you can actually measure its performance, like properly measure it.
And critically, what steps you can actually take, what you can do to get towards what they call operational excellence.
Right. You're going to walk away understanding some common problems much better, and hopefully with some practical solutions you can apply, whether that's, on a factory floor or maybe just keeping things running at home. So let's get into it.
Let's do it.
Okay, so let's unpack this. When we first think about why equipment breaks down,
Mm-hmm.
what usually springs to mind? For me, it's like a worn out part, maybe.
That's the common thought, yeah. A specific component just fails, reaches its end of life. But what these materials really hammer home is that the root causes, they're often way more subtle, almost insidious.
Okay.
They call out three major contributors that honestly often fly under the radar. The first one is contamination.
Contamination. Okay, so like dust and grime.
Well, yes, but it's broader than that. It could be too much of something getting in, or maybe not enough of something essential like coolant, or even just the wrong type of substance.
Like using the wrong oil or something.
Exactly. Or even a tiny bit of grit in the wrong place, causing huge amounts of wear over time. It's pervasive.
Okay, number one, contamination. What else?
Number two is vibration. That sort of subtle shaking, it can quietly destroy equipment from the inside out, often caused by overloading the machine or maybe just poor alignment, lack of basic maintenance.
Right, that makes sense. Things literally shaking themselves loose.
Precisely. And the third one is lubrication issues.
It seems so basic.
It does,
Yeah.
but it's shocking how often it's the culprit. Simple things like poor housekeeping leading to contaminated grease, or just inadequate attention to lubrication schedules. These three are huge underlying factors.
Contamination, vibration, lubrication. Okay. But the materials also talk about something they call the real problem, right?
Yeah.
Which seems to go beyond just the nuts and bolts.
That's spot on, because you can understand those three things, but actually doing something about them is another story. That's where the organizational, the human element comes in.
So have you seen situations where maybe people know about contamination but still struggle? What's that deeper hurdle?
Oh, absolutely. That's often the crux of it. The sources point out that the deeper challenge is often we don't know what to do, or maybe even more commonly, we just don't know where to start. It feels overwhelming.
Yeah, I can see that.
Add to that maybe not having easy access to the right maintenance manuals, or perhaps there's a skills gap in the team. People haven't been trained on these specific techniques, these human and knowledge gaps. They're just as critical as a broken gear, maybe more so.
Okay, so that's the real problem.
And that's exactly where the solution proactive maintenance comes in. It's designed to cut through that feeling of being overwhelmed.
How does it do that?
Well, it helps you first prioritize the opportunities. Where's the biggest bang for your buck? Then it gives you a framework, a structure for taking action. And crucially, it focuses on two things: equipment stabilization, getting things under control, and building team knowledge.
Oh, okay. Stabilize and train.
Exactly. And those two together, they lead to real equipment improvement. It's really about empowering the people involved to understand what's happening and giving them the tools to act.
Okay, so we've got the problems identified. We've got a potential path forward with this proactive approach. But how do you know if it's working? How do you measure performance or, as you mentioned, these machine losses? Without numbers, you're just guessing, right?
You're absolutely right. Measurement is key. Otherwise, it's just a hopeful activity. So machine losses, as the material defines them, are basically unrecoverable time, materials, and effort. All that hidden waste.
The efficiency drains.
Exactly. And to figure out where to focus, you first need to understand the types of losses you're experiencing. The sources break them down into three main buckets: quality losses, availability losses, and performance losses.
Okay, 3 types.
Right. And that covers a whole range of things. Obvious stuff like breakdowns, yeah, but also time lost during changeovers between products. Then there are the subtler things.
Mm.
Minor stops, maybe the machine running just a bit slower than it's designed to, yield loss, defects, rework.
Wow, okay. That is a lot of ways to lose efficiency and money.
It really adds up, which is why the core metric these sources push is overall equipment effectiveness, or OEE.
OEE. Heard of it, but break it down.
Sure. It's actually a pretty powerful way to quantify how well you're really doing. The formula itself is quite straightforward on the surface. OEE equals your availability percentage times your performance percentage times your quality percentage.
Availability X. Performance X quality.
Oh, yep. It boils down to a single number that tells you how much good product are you making compared to how much you could be making if everything ran perfectly, perfect speed, zero downtime, zero defects.
Got it. So let's dig into those percentages. What's availability?
Okay, availability percentage. This is all about the actual time your equipment is available to operate after you account for all downtime planned and unplanned.
All downtime, like everything.
Everything. Think of losses here as any time the machine is supposed to be running but isn't. So yes, full breakdowns count, but also things like waiting on materials, or maybe the operator isn't there. Even planned stuff like equipment changeovers, the setup time, adjustments needed between running different products. All that time is lost. You can't get it back.
Okay, that's availability, time lost.
Mhm.
What about performance?
Right, performance percentage. This one measures how close your equipment is running to its theoretical design speed. The losses here are often a bit more insidious.
How so?
Well, you've got speed loss. That's the gap between how fast it could run, theoretically, and how fast it's actually running. Sometimes that's intentional, maybe to prevent jams or quality issues, but it's still a loss against potential.
Okay, running slower than possible.
Yep. And the other big one here is minor stoppages. These are those really frustrating short stops. The machine halts, maybe it runs idle for a minute or two, a quick jam, a sensor needs wiping. Things that don't trigger a full maintenance call, but they interrupt production constantly.
Those little stops that add up. I know those.
They add up significantly. And finally, you have quality percentage. This
Yeah.
accounts for the time lost making bad products.
Defects, basically.
Defects, rework, scrap, all of that. It includes what they call startup rejects or yield loss. So stuff you lose at the beginning of a shift while the machine warms up, or maybe after a job change, or even spillage or evaporation in some processes. And then, of course, the straightforward rejects, rework, or scrap defective materials, bad products you have to throw away. And crucially, the wasted man-hours spent trying to fix things that weren't made right the first time. It's basically good parts out versus total parts started.
Availability, performance, quality. Okay, that makes OBE a really comprehensive measure. It covers time, speed, and good output.
Exactly. It forces you to look at the whole picture.
So what's considered good? The materials mentioned benchmarks, right?
They did. And the world-class benchmarks for OEE are, well, they're pretty eye-opening. An overall OEE of 85.0% is considered world-class.
85%. That sounds achievable.
Well, look at the breakdown. To get 85% overall, you typically need around 90.0% availability, 95.0% performance, and an incredible 99.9% quality.
Whoa, 99.9% quality. That's almost perfect.
It's practically zero defects. It really shows how rigorously top operations chase down every tiny loss. It forces you to rethink what's even possible.
That's pretty amazing. And is there an easier way to think about calculating it without tracking every single minute?
Yeah, the source mentions a kind of back-of-the-envelope way, which is useful, basically.
Yeah.
The number of good units you actually produced, divided by the number of units you theoretically could have produced in that time if everything ran perfectly.
Good units made, total possible units.
Simple.
Simple concept, yeah. Though they also provide examples with all the detailed data shift length, breaks, downtime minutes, ideal cycle time, pieces produced, rejects to show how you'd actually calculate it precisely in practice. It gets quite granular.
Okay, so we understand the losses. We know how to measure them with OEE. Now,
Yeah.
What do we do? How do we start improving?
Right, action time. The approach recommended is called focused equipment and process improvement. Keyword there is focus.
Meaning?
Meaning you don't try to boil the ocean. You bring together the people who actually run the equipment, the operational team, along with maintenance support staff, And then, crucially, you identify, quote, one area of the plant that gives you the most grief. Pick your biggest problem child.
Exactly. Focus your energy there first. Get a win. Build some momentum. Show that the approach works. Trying to fix everything at once usually leads to fixing nothing.
Makes sense. Focus. So once you pick that area, what's the very first step?
A crucial first step is something they call initial clean and inspect, which sounds simple, but it's powerful. You framed it earlier as cleaning with meaning. I like that.
Yeah, it's not just about making it look nice, right?
Not at all. It's fundamentally a diagnostic process. Like your detective analogy, meticulously cleaning to reveal hidden clues. This process actively identifies problems and their root causes while you clean.
So as you're wiping away grime, you're looking for what?
You're looking for subtle things. Maybe slight oil leaks indicating lubrication issues, signs of looseness or wear pointing to vibration problems. You're identifying where contamination is coming from and accumulating. Once you see these hidden problems, you can actually start to eliminate their sources, that tiny crack hidden under dirt. That could be a major failure waiting to happen.
So cleaning with meaning helps you find it before it finds you.
Precisely. It turns cleaning from a chore into an inspection.
And what specifically are we inspecting for during this cleanup?
Good question. You're looking for two types of problems. First, static problems.
Yeah.
Things you can spot when the machine is switched off. Grime buildup, yes, but also scratches, cracks, check for looseness in bolts or fittings, maybe parts that are obviously tilting or misaligned.
Okay, things you see when it's still.
Right. But then you also need to look for dynamic problems. These are things you might only notice when the machine is actually running. Unusual vibration, strange noises, maybe excessive heat.
Got it. Static and dynamic.
And don't forget the hard-to-do areas, those awkward spots that are difficult to clean or get a good look at. That's often where problems like to hide and fester. Pay special attention there.
Okay, so you clean, you inspect, you find all these issues. Static, dynamic, hidden ones. How do you keep track of it all? Make sure things actually get fixed.
That's where a simple but effective system comes in, equipment tagging.
Tagging, like putting labels on things.
Essentially, yes, it's a visual system. You find a problem, a leak, a loose bolt, a frayed wire. You put a tag on it. The tag identifies the problem, maybe suggests an action, assigns responsibility, sets a priority. It's a clear visual way to manage all the follow-up actions needed from that clean and inspect phase.
So nothing gets forgotten or falls through the crack.
Exactly. It creates accountability and visibility.
And once those tags are up and the problems are clear.
Then it's all about continuous improvement. You develop action plans based on what you found, the cleaning insights, the inspection findings, the tagged issues. Prioritize them, fix them, check that the fix worked. It's not a one-off event, it's a cycle. Identify, act, refine, repeat.
Okay, so we've cleaned, tagged, started fixing things in our focus area. We're improving. But zooming out a bit, what about the bigger picture? The long-term strategy for maintaining equipment well? Are there different approaches, different philosophies?
Yes, absolutely. Once you've stabilized things a bit, you need a sustainable strategy. Our sources really highlight two primary, though distinct, maintenance philosophies that organizations often adopt.
Okay, what are they?
First, there's total productive maintenance, usually called TPM.
TPM. Heard that acronym.
Right. TPM is very holistic. It really focuses on empowering everyone involved with the equipment, especially the operators themselves. The goal is higher production efficiency, yes, but also achieving uninterrupted operations and enabling a really quick proactive maintenance response, often right at the source.
So empowering the operator.
Big time. The ambition for a TPM team is often stated as 0 mechanical breakdowns, 0 technical disturbances, and this is key operators can maintain, meaning they can handle routine maintenance, spot problems early, maybe even do simple repairs. It's a culture shift, making everyone feel ownership.
Okay, that's TPM, operator focused, 0 breakdowns goal. What's the other one?
The second main strategy is reliability-centered maintenance, or RCM.
RCM. Okay,
Yeah.
How's that different?
RCM is typically more maintenance-led or engineering-led. It focuses heavily on the criticality of different pieces of equipment, which failures would hurt the most, and on predicting failures before they happen.
Predictive maintenance.
Exactly. The goal in RCM is also to eliminate breakdowns, but the approach is often through highly effective, precisely timed maintenance interventions based on predicted failure patterns, or sometimes even through redesigning the equipment itself to make it inherently more reliable.
So less about day-to-day operator involvement, more about analysis.
Generally, yes. A key tool in RCM is something called failure mode effect analysis, or FMEA.
FEA.
Yeah, it's a very systematic way to brainstorm every possible way a piece of equipment could fail, understand why it might fail, the failure mode,
Right.
predict the effect or consequence of that failure, and then figure out how to prevent it or mitigate the risk. RCM teams dive deep into the process, pinpoint potential faults or weaknesses, and then implement fixes, often engineering solutions, to make the system more robust.
Okay, so TPM is broad, operator empowering, aiming for zero disturbances. RCM is more focused, analytical, predictive, often maintenance-led, especially for critical assets.
That's a good summary. TPM might be great for high-volume lines where quick operator action is vital. RCM might be essential for, say, a critical complex piece of machinery where failure is catastrophic and needs deep engineering analysis to prevent.
Right. So as you're listening, you might think about your own situation. Does one sound like a better fit? Or maybe, like a lot of things, some kind of hybrid approach, taking the best bits of both, might be the way to go.
That's often the case in practice, yeah, using elements of both.
Okay, let's bring it back down to the shop floor then. We talked about the big three failure contributors earlier: lubrication, vibration, contamination. Let's dive into some specific practical solutions operators can actually use to combat these. Starting with lubrication.
Right, and this one is huge. The sources quote a pretty shocking statistic. Something like 60 to 80% of breakdowns in moving parts are due to poor lubrication or oiling.
60 to 80%. Seriously.
Seriously. It's massive. It just underscores how critical getting this seemingly simple task right really is.
Okay, so how do we get it right? What are the key things?
Well, several things. First, lubrication frequency. How often? How much? It totally depends on the equipment and how it's used. Too little lubrication, obviously parts wear out fast, but too much can also cause problems overheating, seals blowing, attracting dirt.
So there's a sweet spot. The Goldilocks zone.
Exactly. And it might be time-based every week or usage-based every 1,000 cycles. Second is lubrication type. Are you using the correct lubricant for that specific bearing or gear? Using the wrong grease, even if it's high quality, can cause big problems.
Okay, right frequency, right type. How do you make that easy? Avoid mistakes.
That's where mistake proofing comes in. Simple things like clearly identifying every single lubrication point on the machine, maybe using color coding, red grease gun for red lube points, blue for blue, etc. Match the gun to the point.
Simple, visual. I like it.
Very effective. And this all ties into having clear lubrication standards and training. Everyone needs to agree on what good looks like, how to monitor levels, maybe use simple checklists, and of course, proper training is essential.
Right.
Visual management is also huge for lubrication. Simple visual cues, clearly marked lube points, maybe sight glasses with clear min-max levels marked, ensuring there's no spillage which attracts dirt, making sure reservoirs are kept topped up. Keep it obvious.
Makes sense. What about automating it?
Yeah, automating the lubrication system can be a great solution for critical or hard-to-reach points. These systems deliver the precise amount of lubricant at exactly the right time, prevents under and over lubrication, keeps contaminants out, reduces manual labor.
Okay. And what about daily checks? What should operators be looking for?
Good point. Introduce simple daily checks. Operators should ask themselves, is the lubricant actually reaching the moving parts? Are the levels and maybe temperatures okay? Any signs of leaks? Is the lubricant discolored or dirty? Any unusual noises coming from lubricated areas? Is consumption suddenly way higher than normal? These quick daily questions can catch problems super early.
Wow, that's a lot just for lubrication. But that 60-80% number makes it clear why it's so important.
Okay.
Let's move to the second one, vibration, the shaker.
Right, the one that literally shakes things apart over time. Vibration often comes down to either poor machine design, maybe it wasn't robust enough to begin with, or it's being overloaded, run too hard, or with too much weight.
So what are the fixes?
Solutions usually involve things like replacing worn parts bearings, couplings, doing corrective maintenance like balancing rotating shafts, making sure the machine is actually rated for the load you're putting on it is crucial. Sometimes you might even need to upgrade to heavier duty fittings or supports if vibration is persistent.
Okay, fixing the root cause. Can you dampen it?
Yes, definitely. You can actively reduce vibration by installing specialized shock or vibration isolators like rubber mounts or spring systems. And ensuring fasteners stay tight is key. Using things like spring washers, star washers, or lock nuts helps prevent bolts from vibrating loose over time.
Makes sense. How do you spot vibration issues visually?
Visual management for vibration often involves alignment markings. Simple lines of paint across a bolted joint, for instance. If the lines break, you know something has moved or loosened.
Oh, like a witness mark.
Exactly. You can also use markings to check the tension on chains or belts or spot misalignment between coupled shafts. The sources even suggest using clear perspex covers sometimes, maybe with quick release fittings, so you can easily see inside without stopping the machine or removing heavy guards. Just a quick glance.
Clever. And the daily checks for vibration.
Similar idea to lubrication, operators ask. Has anything moved from its alignment mark? Is anything visibly loose or rattling? Are there any new wear marks appearing where things might be rubbing? And critically, does the machine sound different? Is there a new hum, buzz, or rattle? Changes in sound are often the first sign of a vibration issue.
Okay, good questions. Finally, the third one. Contamination. The dirt, the grime, the unwanted stuff feels like a constant battle sometimes.
It can feel that way, yeah. The main goal with contamination is to try and contain it at the source. If you can stop it getting out or getting in, you drastically reduce equipment wear and tear, and you spend way less time and effort cleaning up.
Containment at source. How?
Using containment systems. Think simple guards or deflectors designed to keep material in like product dust or keep unwanted stuff out like dirt from the environment. Dust extractors pulling contamination away at the point it's generated are another key tool.
Okay, physical barriers and extraction.
Right. And crucially, linking back to our earlier point, operators need to introduce daily cleaning and inspection as a routine. Know where needs cleaning, how often. Actively look for new sources of contamination that might have appeared. Think about how existing containment could be improved. And always look for ways to make the cleaning process itself easier and faster. Turn cleaning into that proactive, diagnostic activity again.
Right, cleaning with meaning applies here too. Looking for the why behind the dirt.
Exactly.
So all these specific solutions for lubrication, vibration, contamination, they sound great, but rely on operators noticing things. How can we make that easier for them? You mentioned visual controls earlier.
Yes. Visual controls are all about making these checks super quick, super easy, almost intuitive for the operator. Taking complex information and making it simple to understand at a single glance.
Give me some examples.
Okay, think about a pressure gauge. Instead of just numbers, you mark a clear red zone for dangerous pressure and a green zone for safe operating range. Instantly clear if it's okay or not.
Yeah, okay. Simple.
Or use those temperature-sensitive labels you can stick on motors or bearings. They change color if something overheats. You spot it immediately without needing a thermometer gun.
Clever.
Simple labeling showing which way to turn a valve for open or close. Flow direction arrows on pipes so you know which way fluid should be going. Even something as simple as tying small fabric streamers to air outlets if the streamer's fluttering, air is flowing. No streamer movement.
All the
Problem.
visual cues everywhere.
Yeah, exactly. And these visual controls work hand in hand with things like operator inspection checklists, simple lists guiding them through the key checks for specific equipment, like a limit switch check or an oil pressure pump check. It provides structure, ensures consistency, makes sure nothing important gets missed day to day.
Okay, that paints a really practical picture. It's about making it easy to do the right thing.
That's the core idea, yeah.
Right.
Simplify, visualize, empower.
Wow, okay. We have covered a lot of ground today in this deep dive on proactive maintenance strategy.
Yeah.
It's been fascinating. We started by really unpacking the root causes of why equipment fails.
Yeah, moving beyond just broken parts to contamination, vibration, lubrication, and critically, those human and knowledge gaps, the real problem.
Right. Then we got into the nitty-gritty of measuring performance with overall equipment effectiveness, OEE, breaking down how availability, performance, and quality losses chip away at your efficiency.
And looking at those world-class benchmarks like 99.9% quality, really resetting expectations of what's possible.
Absolutely. Then we shifted to action. We
Sure.
talking about cleaning with meaning, that detective work phase, and using equipment tagging to manage the fixes systematically.
And we explored those two big strategic philosophies. TPM, focusing on empowering everyone, especially operators.
And RCM, with its deep analytical predictive focus, particularly for critical assets, understanding that choice, or maybe the hybrid approach.
And finally, we circled back to those big three: lubrication, vibration, contamination detailing, really specific, practical operator-level solutions.
Yeah, things like mistake-proofing lubrication, using visual alignment marks for vibration, containing contamination at the source, and tying it all together with those clever visual controls and daily checks, making it easy to spot problems early.
Exactly. And I think the key takeaway really is that gaining this knowledge, implementing these practices, it's not just about fixing things after they break. It's fundamentally about creating an environment, a culture of continuous improvement and operational excellence.
Shifting from reactive to proactive.
Precisely. And recognizing that the operator's role in that daily monitoring, those simple checks, those visual inspections, it's absolutely crucial. It really does make maintenance everyone's job, and that shifts the whole game from firefighting to strategic foresight.
So here's a final thought for you, our listener. Considering everything we've discussed today, what's one piece of equipment in your own daily life? Could be at home, could be at work, or maybe even just a routine task you do. Where applying a bit of cleaning with meaning or setting up a simple visual control might reveal some hidden inefficiency, or maybe even prevent a future problem for you.
Yeah, think about it. How could some of these industrial principles apply, even in a small way, to your own personal operations? You might be surprised what you find.
Definitely something to ponder. Until next time, remember, keep it clean, green, and lean.